In this lesson, we're going to get into the mathematics behind acceleration and how we can use it to actually calculate a change in velocity. Now, first thing we need to do is we need to remember that acceleration, by definition, is the rate of change of velocity. It's a measure of how quickly velocity changes. I have a bunch of velocity time graphs over here. So all of these show a changing velocity except for this golden colored one. Okay, that yellowish orange gold thing, that shows a constant velocity of 3 meters per second. So this thing, the gold one, has an acceleration of 0 meters per second. It has no change in velocity. Okay, the velocity is constant, no acceleration. You'll notice the thing that's moving the fastest at the very beginning is this object because it has the highest velocity. It also has the least acceleration. So acceleration is not a measure of speed. It does not tell me how fast something is moving. Okay? It does tell me the rate at which the velocity changes. It does not tell me an object's direction. And here's what I mean by that. Okay? If you'll notice, this red object, this blue object, and this yellow object are all moving away from the reference point the entire time because they have positive velocities. This green object is also moving away from the object or from the reference point for the first 2 seconds. But if we take a look at them, the blue one has a positive acceleration, the red one has an even more positive acceleration, the green one has a negative acceleration. The slope of the velocity time graph tells us about the acceleration, but it does not tell us about the direction of the motion. Remember, positive velocity is moving away. This green line just shows it getting slower for the first 2 seconds. So let's take a look at what all these lines show. They all show the rate at which the velocity is becoming more positive or more negative. This red one is getting faster than this blue one. Okay, the blue one is getting faster. It started fast and it's getting faster. The red one started slow and is also getting faster. You'll notice by the time 4 seconds comes around, both of them have hit the same speed of 4 meters per second. That means the red line is actually accelerating at a greater rate. It's got a steeper slope. It's getting faster than the blue one. Now the other one to look at is this green line. Okay, you'll notice it starts at positive 2 meters per second, crosses the axis here, and ends at negative 4 meters per second. So let's look at what's happening. This velocity is positive, but it's headed towards 0, so it's becoming less positive. We say it has a negative acceleration because its velocity is decreasing. It's moving at 2 meters per second, now 1 meter per second, now for a split second it's at rest, and now it's actually speeding back up, but it's moving towards the reference point. And the acceleration here is still negative. It's negative 1 meter per second for the entire duration. So let's do a little bit of math. Okay? So acceleration, a measure of how quickly an object's velocity changes. It has units of meters per second, or how much the speed changes every second. Okay? The equation for calculating acceleration is the equation for calculating slope. Remember, on a velocity time graph, we have velocity on the side, we have time across the bottom, and so if this line looks like this, then slope is rise over run. Well, that rise is the change in velocity, the run is the time, so what we have is acceleration is change in velocity divided by time. So we can use this equation to calculate acceleration. Okay. If we need to find the velocity after a certain acceleration, then all we have to do is rearrange this equation. If we have acceleration equals change in velocity over time, then all we have to do is multiply both sides by time. That cancels this side, and we get the change in velocity is equal to acceleration times time. Now, if we assume that the initial velocity was 0, or it wasn't moving to begin with, then we just have velocity over here. Okay, so let's work an example problem. Amy's sled starts at rest at the top of a hill. After 3 seconds, she's going down the hill at 7 meters per second. What is Amy's acceleration? Okay, like always, when you guys are working math problems, I expect to see your list of knowns and unknowns over here. So right here it says Amy's sled starts at rest at the top of a hill. At rest is telling me how fast it was going initially. So my initial velocity is 0 meters per second. After 3 seconds, so now I just got a time, 3 seconds. She's moving down the hill at 7 meters per second. velocity is 7 meters per second. What is Amy's acceleration? So here's what I'm looking for. Alright, so acceleration is equal to change in velocity divided by time. Change in velocity, whenever we have change in anything, it's final minus initial. So final velocity minus initial velocity gets us change in velocity. For this one, it's 7 minus 0 divided by 3, which equals 7 divided by 3, which equals 2.33333 meters per second. Okay, that's 2 1/3 meters per second, but then we divided it by seconds, so per second. What this tells us is Amy's getting faster by 2.3 meters per second each second. Okay. Another example, a cart starts at rest and accelerates at 0.5 meters per second down a ramp. What is the velocity of the cart after 2.5 seconds? Again, cart starts at rest, initial velocity 0 meters per second. Acceleration, A equals 0.5 meters per second. What is the velocity? So we're looking for how fast it's going after a time of 2.5 seconds. So we're going to take V equals acceleration times time, and we get 2.5 times 0.5, which equals 1.25 meters per second. Okay. We did just find a velocity. We took seconds times meters per second, and so we know after 2.5 seconds she's moving at 1.25 meters per second. Her speed is getting faster by 0.5 meters per second each second, so she's only going that speed for a split second, but we know how fast she's going after 2.5 seconds. Okay. Now, if we look at some acceleration and we look at some velocity time graphs and we're looking at getting acceleration from these, remember, we're just getting slope. So positive acceleration means we have positive slope. So I'm going to draw this line through here. Okay, and this actually shows two distinct motions. Between the times 0 and 2 seconds, this thing is actually slowing down. It's also moving towards the reference point. But from 2 to 6 seconds, it's speeding up, moving away. Now, the entire time, it only has one acceleration, and that acceleration is given by the slope. And we can pick whatever interval we want or the whole thing because it's a straight line. Its initial velocity is -2 meters per second meters per second. Its final velocity is 4 meters per second, which means its change in velocity is 4 minus a -2, which equals 6 meters per second. The time that this took was from 0 seconds all the way up to 6 seconds, which means our acceleration is actually 6 divided by 6 meters per second divided by seconds, or 1 meter per second. Okay? That's the acceleration of the object. Even though it's moving in two different directions, it always has a positive velocity or positive acceleration because the velocity is always becoming more positive. -1 is more positive than -2, 0 is more positive than -1, 1 is more positive than 0. So each second this thing becomes more positive in its velocity. Therefore it has a positive acceleration. If we go to a negative acceleration, it's exactly the same thing. Again, it does not matter which way the object is moving. So for the first 3 seconds here, I have this thing moving towards the reference point, getting slower. So the 3, then 2, then 1, then 0, this velocity is becoming less positive, closer to 0, and then from 0 it goes -1, -2, -3, and so our velocity is becoming more negative. So again, we have an acceleration that is always -1. Acceleration is -1 meters per second, but all it shows is the velocity becoming more negative. It does not tell me which way the object is moving. It does not tell me how fast the object is moving. It just says every second the velocity becomes more negative by 1 meter per second. The steeper the slope, the more the object's velocity is changing. So if we take a look, if I were to have something that looked like this, okay, it is also changing velocity, but it's not changing its velocity nearly as quickly. If the slope is positive, the acceleration is positive, and the numbers are getting bigger or more positive. So not necessarily bigger, just necessarily more positive. If the slope is negative, then the acceleration, the velocity is becoming more negative. Now, here's a problem we can take a look and we can solve. So, if we look at these objects, both of them are moving towards the origin. Okay, it doesn't matter which line I'm looking at, object 1 and object 2. I can tell they're both moving towards because they're negative velocities. They're moving in a negative direction. Both of them also have negative accelerations. Okay? The reason they have negative accelerations, I can tell, is because the slope is negative, their velocity is becoming more negative. Are they speeding up, slowing down, or going to constant velocity? Well, they start at 0 meters per second and they end at not 0 meters per second. So I know that they're changing speed, and if they started at 0, any change in speed is necessarily going to make them faster. So this means they're speeding up. And the acceleration of object 1. Well, we need to find the slope of that line. It goes from 0 meters per second to negative 2 meters per second. So the rise is actually negative 2 meters per second divided by the run, which is 7 seconds. Okay, so our acceleration is negative 2/7 meters per second per second. Okay, if we go to the acceleration of object 2, it's accelerating a little bit quicker, which means its acceleration is higher, its change in velocity is greater per each second, and so we're going to calculate the slope the same way, but this time we're going to have negative 3/5 meters per second per second.